Hi everyone, welcome back to the Oracle Chef YouTube channel and thank you for waiting for the Oracle Architecture video. In today's video, we are going to deeply understand Oracle single instance architecture step by step using visual flow diagrams. We'll understand how client connection works, how memory structure operates, how Oracle processes SQL, how background process function, and how Oracle safely writes and protects data. So let's start from the core foundation of Oracle architecture. Oracle Server mainly consists of two major components. One is instance and one is database. Instance represents memory structures and background processes. Database represents the physical files stored on disk. Together, both from the Oracle Server architecture. So whenever a client sends a SQL request, the connection first reaches the Oracle listener. Then the listener transfers the request to the server process. Listener itself does not process SQL requests. Its responsibility is only to accept the connection request and hand it over to a dedicated or shared server process. The server process then communicates with Oracle memory and database structures. Its responsibility is only to accept the connection request and hand it over to a dedicated or shared server process. The server process then communicates with Oracle memory and database structures. Once the SQL reaches the server process, Oracle first checks the shared pool. In shared pool, we have library cache that stores past SQL statements and execution plans. Data dictionary cache stores metadata information about database objects. If the SQL already exists in memory, Oracle can reuse the existing execution plan, which improves performance and reduces parsing overhead. Oracle checks the buffer cache after parsing. Buffer cache stores frequently accessed data blocks in memory. If required blocks are not available in memory, then Oracle reads them from the data files into the buffer cache. When data gets modified, the modified blocks become dirty blocks. These dirty blocks are later written to data files by DB writer process. Oracle instance uses memory structures and background processes together to process SQL requests efficiently. The major memory structures inside Oracle instance are SGA and PGA. So inside SGA, we have SGA stands for System Global Area. It is shared memory accessible by Oracle processes and user sessions. SGA mainly contains of buffer cache, shared pool, redo buffer, Java pool. Java pool supports the Java execution inside Oracle database. Large pool is used for large memory allocations such as ARCn operations, parallel execution, and shared server operations. Shared pool is responsible for SQL parsing and execution planning. Library cache, it contains shared pool contains library cache and data dictionary cache. This helps Oracle efficiently reuse SQL execution information. The flow happens like this. Buffer cache stores database blocks in memory. This helps Oracle reduce physical disk reads and improve performance. Modified blocks remain in memory as dirty blocks until DB writer writes them to data files. Then comes to redo buffer. Redo buffer temporarily stores redo entries generated by transactions. These redo records are critical for database recovery and durability. Redo information is written before data file writes occur. Then comes to PGA. PGA is Program Global Area. PGA, unlike SGA, PGA is mainly used for sorting, hash operations, stack space, and session specific operations. Oracle uses multiple background processes to maintain consistency, recovery, memory management, and write operations. Now let us understand the Oracle background process. You can check the multiple background processes and their responsibilities. So the DB writer or database writer process writes dirty blocks from buffer cache into data files. This ensures modified data eventually gets persisted to disk. Log writer or LGWR process writes redo from redo buffer into redo log files. Redo is always written before modified data blocks are written to data files. Checkpoint process signals checkpoints and updates checkpoint information in the control files and data file headers. Cleanup. PMON cleanup. PMON process monitors cleanup failed user processes and releases resources. SMON or system monitor. This is the major background process. Performs instance recovery during database startup after abnormal shutdown. Archiver process performs archives redo logs into archive log files for backup and recovery purposes. So these are all the six background processes. And coming to database, we have data files, control files, archive logs, redo logs. Oracle database physically stores information inside these four components. Each file type plays an important role in database consistency and recovery. The overall architecture, now we can see the complete single instance architecture together. Client connections reach listener. Listener hands connection to server process. Server process interacts with SGA memory structures and background process. Background process coordinate writes and recovery operations while database files permanently store the information. That was the complete Oracle single instance architecture explained step by step. In upcoming videos, we will extend this architecture into Oracle RAC and understand how Oracle scales from single instance to clustered architecture. If this video helps you to understand Oracle architecture visually, please like the video and share it to others. And comment what topic you want to explore next. And don't forget to subscribe the channel. Thanks for watching. Bye bye.